Hello, calculus students and general seekers of truth. Let us get to this lesson on a very important topic, and that is area functions. And then from here, we're going to go forth onto an even more important topic. But before we get into all that fun stuff, let's just talk about some review of definite integrals. And so here we have two definite integrals to evaluate. So I'm just going to draw a nice big picture here. So say we have this graph. And this is the graph of y equals 2x. All right, so let's see. Y equals 2x is going to look something like this. This has a slope of 2 passing through the origin. Okay, and we want to find the area between 0 and 3. So like 3 is about right here. And this point right here is 3, 6. So the definite integral is going to be this area right here, which is just the area of a triangle, right? And this is like a right triangle. So this is 1/2 of the base, which is 3, times the height, which is 6. So we work all that out. That equals 9. For our second example, we are going to integrate, and we're not just going to go to 3, we're going to go all the way out to 4. So this green line right here, and this point here would be 4, 8, since we're working with the line y equals 2x. So this green area right here is also a triangle. It's going to have an area formula of 1/2. The base, which is 4, times the height, which is 8. So we're going to end up with an equation 16, okay? Or an answer 16. So there we have it, some very simple basic examples and review of a definite integral. Now let's continue and let's discuss an area function. And so we're going to define a function in terms of the area. So what does it, and we're going to call this function big F of x. So let's talk about what this function machine really does. Big F is going to take in an x coordinate, and it's going to output an area. And what area will it produce? Well, it's not too difficult to ascertain. We can see here that you're going to still have this line y equals 2x passing through the origin there. So this is the line y equals 2x. Now what often troubles people is that I have to change this variable from an x to a t. The reason is that the variable x and the variable t, they can't refer to the same thing. They mean slightly different things. Okay? And so t here is really a dummy variable. So, and I'll say this, t helps us determine how to draw the curve. Okay, so this is the input to draw the curve. Okay, so this curve y equals 2t. And x is the input to determine the definite integral, or the area. So in other words, if I plug in f of 1, so f of 1 is the area, is this area right here between from 0 to 1 underneath this curve. So you see, x is along this horizontal axis, t is along the horizontal axis, but the input to t helps us to draw this curve, and the input to x helps us to determine where to draw this area. So we have to just use a different variable. They cannot be the exact same thing. Okay. Well, let's complete this table. We actually already figured out two points already. We know the value at f of 3, right? Because f of 3 is nothing more than the integral from 0 to 3 of 2t dt, which we already figured out in the previous problem was 9, and we already figured this out that this was 16. And so let's figure out the rest. So if we want to find f of 1, we plug 1 here. This point here is going to be 1, 2. So you have a triangle with an area formula 1/2. The base is 1. The height is 2. So you're going to get 1. We change up the colors here a little bit. So now let's say we have, f of 2. We go out to 2. And we want to now find the area of this red triangle, which incidentally includes the previous green one. So this is 2, 4. So we have a triangle with area 1/2. The base is 2. The height is 4. And this is going to give us a value of 4. And finally, if we go all the way out to 5. So we go out to like here, like to 5. Then this point here is 5, 10, and we want this entire blue region, which includes all of the previous ones. This would have an area 1/2, the base is 5, and the height is 10, so this will have 25. So our values here are f of 1 is 1, f of 2 is 4, f of 3 is 9, f of 4 is 16, and f of 5 is 25. All right, now I'm going to continue one more example here. This time I'm going to define a function g as follows, and the only thing that g is different from f is that it starts, g, the integral starts at 3. So you still have this equation. This is y equals 2t. All right, but instead of integrating from 0, we're going to start integrating from 3. So this is 3. This is has the point here of 3, 6. And now we're integrating g of 1. Let's see. G of 1 is going to be the integral from 3 to 1. So this point here is 1. We're going to integrate this. This point here is 1, 2, and we're essentially finding this area right here. Now notice that the lower limit is bigger than the upper limit, so this is going to give us the negative. Okay? So this is really the negative of this area. So this is really negative integral from 1 to 3 of 2t dt. And here is where the trapezoidal property applies. That area is really 1/2 the base of the height of the trapezoid, which is this length right here. Remember that the height of the trapezoid has to be perpendicular to the two bases. So the height here is 2, and the bases are 2 and 6. And this is going to give us 8. Okay. But it's going to be a negative 8 because we're integrating from right to left. So it's going to be the negative of whatever our answer is going from left to right. So I'm going to move through the other points here on the table relatively quickly. You should work this out for yourself and ask your teacher if you're having a hard time with this. But g of 2, I'm going to tell you is going to be negative 5. G of 3 is going to be 0. That's the easiest one, so maybe I should write this on the side here. G of 3 is really the integral from 3 to 3, because we're substituting in 3 for x here, of 2t dt. But when you're trying to find an area of a line segment, essentially it's going to be 0. G of 4 is going to be 7, and G of 5 is going to be 16. Okay. So again, I did this pretty quickly. But you should really figure this out for yourself. It's actually pretty good practice for you in working with definite integrals. Okay. Now, the real magic happens in the next video when I'm going to compare the two functions f and g. So I'm going to end this video here and let you watch the next one. As always, thank you for watching and have a wonderful day.